Lesson 3's homework starts with this. The first ones are asking you for points of discontinuity. So what that means to be discontinuous is where the denominator equals 0. So what I would do is try to factor out my denominator first. So I know that I can factor that into x and x minus 2. Well, then I want to set both of those equal to 0. So when I do that, I'm going to get x equaling 0 and x equaling 2. Okay, on number 2, the same thing. You can either choose to factor this or you can solve it, whatever you want to do. If you want to factor it, it's going to factor into x plus 1 and x minus 1, and both of those are going to get set equal to 0. So then I'm going to get x equals negative 1 and x equals 1 as my two solutions. You could have set it equal to 0 to begin with and then just had to take the square root. That would have been an okay option to do too. Number 3, same thing, I have to factor. So I'm saying, okay, what multiplies to 8, that adds to negative 6. Well, what's going to do that is negative 4 and negative 2. So my denominator is really going to be x minus 4, x minus 2. I said that backwards. So set both of those equal to 0. And solve. And those are your two solutions for that. Okay, same thing here. This one's just a little bit harder because you have to multiply your factoring first. So it has to add, or multiply to negative 10 and add to 9. So what's going to do that is positive 10 and negative 1. So then I have to rewrite that as 2x squared plus 10x minus x minus 5. Greatest common factor these. 2x is my greatest common factor. X plus 5, negative 1, x plus 5. So now I have my denominator that I can set equal to 0. I can say 2x minus 1 equals 0, and x plus 5 equals 0. Okay, so this one is going to give you 1/2, and this one is going to give you 5. That factoring is a good review for the final because that will definitely be on there. Okay, so that is the first 4, is just setting the denominator equal to 0. Looking through the next one, you're looking for wholes and asymptotes. Asymptotes is when you can set the denominator equal to 0, and wholes are when you can remove something from it. So in number 5, there's nothing that I can remove from this, so I'm just going to set that equal to 0, and I get x equals negative 3, and that's an asymptote. Okay, and there are no wholes because there's nothing that I can remove from that. My next one, I'm going to try and factor that one. So the numerator is going to become x plus 2 and x minus 2. The denominator is going to become x minus 2. Okay, so with this now, I can cross these out, but when I cross them out, I know that that means a whole. Okay, so I'm going to have a whole at x minus 2 equals 0. So I'm going to have a whole at x equals 2. In terms of an asymptote, I'm going to look at my new equation and see what the denominator is. Well, my new equation has no denominator, so there is no asymptote. Okay, so wholes are things you can remove. Asymptotes are what the denominator is when you set it equal to 0. Looking at number 7, is there anything I can cross out from that? No, there's not. So this is going to have two different vertical asymptotes. So I'm going to set these both equal to 0. And solve for both of those. So this is going to give me negative 3/2 for x, and this is going to give me negative 1, and these are asymptotes. Okay, because I can't remove them, there are no wholes. Because there's nothing that I could cross out. If I could cross anything out, that would give me wholes. Looking at number 8, can I factor that? Is there anything that multiplies to 3 that adds to 0? Well, no, there's not. Okay, so there's going to be no wholes because there's nothing I can get rid of. And in terms of asymptotes, set this equal to 0. I get x squared equals negative 3. So I get x equals plus or minus the square root of negative 3. Well, that's going to be imaginary. Okay, so no asymptotes either. Can't have anything imaginary. So this one has no wholes and no asymptotes in it. Okay, the next one I need to factor down. So when I factor both of these, I'm going to just go ahead and tell you what the factors are. so that I don't have to spend quite as much time on this. Here's your numerator, factored down, and your denominator is also going to be 2x plus 3 and x plus 5. Okay, so if we were just finding asymptotes on this, we would set both of them equal to 0 in the bottom. But what I know is that these two can cross out, so that's going to be a hole. I'm going to have a hole at 2x plus 3 equals 0. So my hole is going to be at x equals negative 3 halves. Then I'm going to look for what my asymptote is going to be on this. Okay, so my asymptote for this is going to be what's left over. So that's going to be at x plus 5 equals 0. So at x equals negative 5. So holes and asymptotes. Number 10, same thing. We're going to see if we can factor this. So I'd rearrange the top and make it negative x squared plus 4. And then I would factor out a negative because that's just hard to work with. Okay, so when you do that, this makes it be able to factor. So you have a negative sign, and then x plus 2 and x minus 2. The denominator on this is x plus 2 and x minus 2. So both of these are removable because you could cross both of those out. So I'm going to have two holes. I'm going to have a hole at x equals negative 2 and at x equals 2. No asymptotes because what I'm going to be left with is the equation negative 1. Next page of this, you want to find the horizontal asymptotes of this. So the horizontal asymptotes are comparing what you have. So the top, in this one, my numerator has no coefficient, so a nothing, and my denominator has an x. So what I know is the numerator is less than the denominator. When it's less than the denominator, it's y equals 0. Number 12, my numerator is x, my denominator's highest is x, so they're equal to each other. So when they're equal to each other, we do y equals a over b. Okay, so a over b in this case is whatever is attached to my x value, so y is going to be 4 over 3 for this. My next one, going to be the same way here. My numerator is x squared, my denominator is x squared. They're equal to each other, so it's going to be y equals a over b. A over b is what it's attached to, so 1/2 is equal to y for this. Then my last one, my numerator is x, my denominator is x squared, so it is less than in this one. So with it being less than, I just get y equals 0. Graphing. These ones might take you a little bit of time, so I want to find my asymptotes for this. So my vertical asymptote, remember, is when I set the denominator equal to 0. So I'm going to get one at x equals 3. Okay, so x equals 3, dotted line going down. My horizontal asymptotes for this, let's check our numerator denominator. Okay, so my numerator is 0, my denominator is x, so that is less than, so when it is less than, it's y equals 0. Okay, so when y equals 0, that's going to go right here. So just because of the asymptotes that we have, what we know is x-intercepts. None. We can't have one, because what that means is something is going to be on the x-axis, but there's an asymptote there. Okay, so I can't have one. But what I can have is I can have a y-intercept. My y-intercept is when x equals 0. So I'm going to plug that into my equation. 2 over 0 minus 3. 2 over negative 3, which is about negative 0.66. Okay, so when I put that in, negative 0.66 is about right there. So it's 1, 2, 3 away and a half down. So I'm going to go 1, 2, 3 the other way and a half up. And then I have to pick one other point to use. Well, I would use 1 and plug that in. And when you plug in 1, you're going to get y equals 2 over 1 minus 3. 2 over negative 2, which is negative 1. So I get 1, negative 1. And then that's 1 2 over